Welcome to Anacostia Maritime. My name is Captain Alfred Jamal Watson, and today I'll be presenting you with an Azimuth full video instruction. On 6 November, your 0752 zone time DR position is latitude 25 degrees, 11 minutes north, longitude 76 degrees, 7 minutes west. At that time, you observe the sun bearing 119 degrees PSC. The chronometer reads 12 hours, 53 minutes, 7 seconds. And the chronometer error is 1 minute, 19 seconds fast. The variation is 3 degrees west. What is the deviation of the standard magnetic compass? All right. First thing first, I see what is the deviation of the standard magnetic compass. I automatically know that, hey, this is an azimuth problem. Okay. The second thing I think, oh, an azimuth problem. What kind of azimuth problem? And here it says the sun. So since I've been doing this for years, and even since day one, when I first started learning, it's about the reps. It's about repetition. All right. And the way I lay out my problem is the same exact way every time. Let me show you. ZT. Oh man, I'm messing up. Sorry about that. ZT. ZD. GMT. CT. CE. True GMT. All right. Then I have GHA of the sun, the minutes and seconds of the sun, true GHA of the sun. All right. Plus east or minus west longitude. And that would give me the LHA of the sun. Okay. Up here I have my latitude. Let me give a little bit more space here. Latitude, longitude, bearing, variation. Okay. I have my declination, D number, D correction, and my true declination. Okay. The same exact way every time. All right. So I have my problem here. I'm going to write down everything that's given to me. Okay. Everything that's given to me, I'm going to write down. So I have my zone time 0752, 6 November. You always want to make sure you pay attention to the date. All right. 25 degrees, 11 minutes north, 76 degrees, 7 minutes west. And the bearing is 119 degrees PSC, 3 degrees west. All right, I have everything that's given to me. So the first thing I need to do is figure out the zone description. And it's a few ways I can do that. The easiest for me, all right, is going into the Bowditch. All right, they have a table there for me. So let's go with the Bowditch. All right, and I love the Bowditch 1981. That's my baby. All right, you should see my actual Bowditch. I'm never giving it up. All right, let's scroll. And we're going to scroll to page 370 of the 1981 Bowditch. All right, table 36. I already got it highlighted here. Let me show you guys. Okay. You see I got it highlighted here. You see you have west longitudes, and you have east longitudes, all right? These are the zone descriptions, all right? The time zones, okay? I'm going to take my longitude of 76 degrees, 7 minutes west, and I'm going to find out where that falls in, all right? And you can see it falls in between 67 and a half and 82 and a half. That is going to give me a zone description of +5. Easy peasy. All right, so I'll go into my +5, all right? Now, the other way of doing it is by using a calculator. I would then need to turn my longitude into, just degrees. Right now it's degrees and minutes. I will then take my minutes of 7 minutes and I will divide it by 60. That is going to give me a decimal form, all right? That is decimal. That's 7 minutes in the decimal form. Now I need to add the 76 degrees. So 76.116 and then a 7, all right? That is the decimal form of what my longitude is, all right? Now I take my longitude and I divide it by 15 degrees. And as you can see, we have 5, all right? So I know that my longitude is +5, okay? 12 hours, 52 minutes, 00 seconds. 6 November now. Okay, so the next thing I do is I take my chronometer time and I'm going to place it here. It's given, okay? 12 hours, 53 minutes, 07 seconds, okay? And I have a chronometer error of 1 minute, 19 seconds fast. Fast is subtract. Okay, slow is add. In this instance, we have fast. So let's go over here and I'm going to show you guys how to subtract 12 hours, 53 minutes, 07 seconds, right? And we have 1 minute, 19 seconds, right? And we said it was fast, so we subtract. Now, if we look right here, we have the seconds column and it says 7 seconds. How do I subtract 19 seconds from 7 seconds? It's similar to your normal arithmetic, okay? But in this instance, we have to take a whole minute from here and give it to here, all right? So this would then become 52 minutes, right? And that 60 seconds is going to be added to the 7 seconds. So it's going to be 67 seconds now. Now this number is larger and we can subtract the smaller number. All right, 67 seconds minus 19. 67 minus 19, 48 seconds. 52 minus 1. And you might ask, why am I using a calculator? Get in the habit of using a calculator. All right, just get in the habit of continuously using a calculator and double check your answers. Triple check if you have to. 52 minus 1. All right, that was easy to do, but I wanted to use the calculator. All right. So we have 12 hours, 51 minutes, 48 seconds, 6 November. All right. So I have my GMT, all right? I'm then going to go into the Nautical Almanac now, all right? I have my GMT. Now I get to go to Nautical Almanac. Let's find it. All righty. Okay, our Nautical Almanac is for training purposes only, okay? You might notice it's the 1981 Nautical Almanac, all right? That's the one the Coast Guard allows you to go in the classroom with. That's going to also be the one that's all your questions that you might have encounter with the Coast Guard is going to be based off this 1981 Nautical Almanac. All right. Let's scroll through the daily pages to our date. And as you look at it, I'll slow it down a little bit. You see the dates, the months, the year. All right. So we're going to find November 6th. Okay. Let's see. Come on, come on, come on. Let's see. October. All right, we almost there. Okay. I got it highlighted. So I'm going to zoom in a little bit, right? So we're going to extract from this page here, this daily page, November 6th, right? We have the sun here, and we see the GMT. This is in hours only. Like, so if you look at this section right here, this is in hours, okay? So we go down to our time of 12. And if you actually have a paper, it's always good to, like in real life, it's always good to use a straight edge ruler or some sort, all right? Because when you're dealing with a lot of these numbers, I mean, you gotta really zone in. Your eyes might be seeing something that's not. And a straight edge will help you, kind of focus them a little bit better. Because you can end up writing down the wrong number. And now you did the whole problem with the wrong number, and that's a bad day. All right, so we're going to extract our GHA, 4 degrees, 5 minutes, all right? And also our declination of south 16, 2.3 minutes, okay? I'm going to take that over here and write it down. 4 degrees, 0, 5 minutes, correct? Let's double check. Yes. South 16, 2.3. Declination south 16 degrees, 2.3 minutes, all right? Now, this D number here. What is that D number? Let me show you. The D number is located at the bottom, and that D number is 0.7. So I write it here. Okay, now, to determine whether we plus or minus this correction, because we're going to obtain the correction in a second, but to determine whether we plus or minus this correction, we have to take a look at our daily page. And if we move our ruler away from the second, okay, so we look in our declination column, right? Okay, and we take, there we go. Are these numbers here increasing or decreasing? In this instance, we have 2.3, 3.0, 3.8, 4.5. It's increasing, okay? It's increasing. So we would then know our correction is going to be added, okay? So let's put a plus sign here. Now we can go back and let's move this out the way for a second. All right, we can scroll to our minutes and seconds, okay? And that's going to be in the increments area. So let's scroll to the back of our book. Keep scrolling, keep scrolling. I'm pretty sure you guys are flipping the pages right now. Okay, so increments, okay? Let me just scroll back up so you guys can see. Okay, it starts, all right? And as you can see, it starts at 0 minutes, 1 minute, and each page has a set of minutes. So you're going to scroll to your minutes. And in this case, our minutes is 40. No, it's 51 minutes. 51 minutes we have. Let's double check. It's always good to double check. 51 minutes. Okay. Man, this thing is sticking, huh? All right, 51 minutes. And I happen to have it highlighted a little bit for you. Let's see if I can zoom in. Okay. So 51 minutes. All right. So we're going to use the 51 minutes. And we also say we're taking a sun bearing. So we're going to make sure Sheesh, why does it keep doing that? Sun bearing. We're in this column here, all right? 51 minutes. We're going to scroll down. You see seconds right here? Seconds. Scroll down to right here. 48 seconds will be 12 degrees, 57 minutes. All right? 12 degrees, 57 minutes. Okay? And we obtain our D correction. So this column here would be your D number. You just follow your D number down. So we have 0.7 D number, and that is going to give us our correction of 0.6. Okay? 0.6 minutes. Okay? Now, I can just add this 2.3 plus 0.6. 2.3 plus 0.6. 2.9. I could have did it in my head, huh? 2.9. 16 degrees, declination, 2.9 minutes. All right. Now, GHA in minutes and seconds. This is always a plus sign, always. All right. You're always going to be adding, okay, to get to your GHA. To get to your true GHA, you're always going to add the minutes and seconds, okay? All right, so let's go to another page and let's get the adding. All righty, we have 4 degrees, 5.0 minutes, and we have 12 degrees, 57.0 minutes. Okay, let's add this up. 5 plus 57. 5 plus 57. That is 62 minutes. We're over 60. So what do? We're going to subtract 60. And that's going to give us a whole hour that we will carry over to the hours column. Minus 60 minutes. That's going to leave us with 2 minutes left over. Okay, so we have 2 minutes left over. And we're going to carry the 1 hour over to right here, right? 1 hour. Or, sorry about that, 1 degree. 1 degree, all right? 60 minutes of latitude or longitude is going to be equal to 1 degree, okay? So we're just going to add this up. 1 degree plus 4 degrees plus 12 degrees. 1 degree plus 4 degrees plus 12 degrees. 17 degrees, okay? That will give us, oh, I'm sorry about that. 12 degrees. And, oh, I'm sorry, no. 17 degrees, 2 minutes. I apologize. 17 degrees, 2 minutes. 17 degrees, 02 minutes. I've been doing this for years, and you can still mess up. That's why you want to double and triple check. All right, double and triple check. Okay, so now it says plus east minus west of our longitude. This symbol is our longitude symbol, okay? So I always circle what my longitude is, and that lets me know minus 76 degrees, 07.0 minutes, okay? That's west. All right. How do we subtract 7 minutes from 2 minutes? Similar to the time, but we're using degrees here. So let's go over here. All right, and create some space for us. All righty. Okay, we have 17 degrees, 02 minutes. And we have 76 degrees, 07 minutes. That's right. We're subtracting, okay? So, in this instance, we're going to borrow a degree. And what did I tell you earlier? 1 degree is equal to 60 minutes. Okay, so this will become 16 degrees. We're going to carry that 1 degree or 60 minutes over to this column here, right? And add it to it. So that will then become 60 plus 2 minutes is 62 minutes, right? Now this number is greater and we can subtract it. 62 minus 7 is 62 minus 7 is 55 minutes. All right. 16 minus 76. 16 minus 76. Sorry. So we have a minus 60 here, but we know we can't have a negative LHA, right? So anytime you have a negative number, right, you're going to add 360. So let's add 360. And anytime you have a number greater than 360, you're going to subtract 360. So if you had 361 or anything above that, you're going to subtract 360, and that will give you your LHA. So in this instance, we added the 360 to our negative number, and we got 300 degrees, all right? 300 degrees. All right. Oh, I keep doing that. All right, so we have an LHA of 300, 55 minutes, okay? All right, now we done worked out our problem, the first steps of it. I'm going to then highlight this. All right, these are the 3 things you need to do what? Enter pub 229. All right, let's go. Pub 229. All right, now let's scroll down. I love this pub. Let's see what we got here. All righty, XXIV. Let me take my highlighter. Oh man, come on now. Don't me like that. I got a highlighter. Alrighty, this table here is what is needed. We're gonna make this table on our blank piece of paper, right? This is what we're gonna do. We don't have to memorize this because it's right here in Pub 229 on XXIV. This is good to know because we don't have to memorize this table. And when you're studying for your exams and you have so much stuff in your brain and it's so full, you got to be able to learn how to take certain things out and put it to the side and say, I got an easier way of remembering how to do that or how to accomplish this. All right. In this instance, we just go to Pub 229. The table's right here. All right. So let's take this table over here and create this table. All right. Alrighty. So we have, oh man, come on now. Actual arguments. And that is going to be declination, latitude, LHA. Those are our actual arguments, okay? Next. Sorry about that. There we go. So our declination is south 16 degrees, 02.9 minutes. Our latitude was north 25 degrees, 11.0 minutes. And our LHA was 300 degrees, 55 minutes, okay? That's our actual arguments. Okay. So now we're going to go with our base arguments. And that is south 16 degrees, north 25 degrees, 300 degrees. Okay, that's our base arguments. Okay. Now we're going to go with our base Z. Our tab Z. And I say down, over, turn, DOT. I'll explain that once we're doing it, okay? All right. Then we're going to go with our Z diff, Z difference, okay? And I'm running out of space here. Our increments and our correction, okay? So our increments will be, oh man, come on now. The minutes, it's going to be all these right here. That's going to be our increments, okay? So in this instance, it's going to be 2.9 minutes, 11 minutes, 55 minutes, okay? All righty. Let's go to our table. Let's go make sure everything's right. Actual, base, arguments, base Z, tab Z, Z diff, increments, and correction. Okay, then we have the total correction, the base Z, the correction, and so on and so forth, all right? So corrections, base Z, correction, Z, Z, N, okay? And I always like to say this right here. I ask this LHA greater. I always just ask myself that question. And one more thing that's important, we have up here, contrary or same. Okay? And I'll just circle the one we're working with, okay? All right, and then down here I will do my, well, I'll do that in a second, okay? Let's go. So we're gonna take our arguments now and scroll down. So our base arguments are 16 degrees declination, 25 degrees latitude, and 300 degrees LHA. So as we scroll down, we're going to notice something right here. The first half of this book is going to be 15 degrees to 22 degrees latitude. All right. This is your latitude. This is your declination. All right. And your LHA will either be in the corner right here or at the bottom, like this, something like this. Okay. So you're going to pay attention to these right here. All right. So let's scroll. Let's find ours. So we know we're on the wrong half of the book because our latitude is 25. So it's not even nowhere near this part right here. So let's keep scrolling. Let's keep scrolling. Let's keep going. Let's see if I can. There we go. I grabbed it on that side. 3, 0. Let's see. I think we're almost there now. I think we're almost there. Come on. Alrighty. Let's see. Here we go. Alrighty. And I got it highlighted a little bit for you guys. So let's take a straight edge once again. In life, you're going to want a straight edge, all right? So we're going to have our latitude column, our declination column, and we have up here our LHA, okay? 300. All righty? So the first thing I'm going to do is write down, you see this Z right here? That is our Z, okay? So our base Z will be 118.5 for 16 degrees of declination and 25 degrees latitude and 300 LHA, all right? 118.5, 118.5, 118.5, 118.5, okay? I'm going to put that there. Now, for the tab, down, over, turn, DOT, all right? So the first number we're going to get is down 1, okay? And that is down 1 declination, okay? It's right here, 119.4. Okay, so we're going to put that right here. 119.4. Then we're going to go, let's get another color here. Go back up to here, 16 degrees, and we go over 1. So we're going to go down, go over 1 to the latitude, right? Because we're in latitude. Over 1 latitude, and that's 118.8. Now you guys probably can't see it's good, so I'll just go like that. 118.8. All right. I'll go mark that down. 118.8. And then the last one is going to be the LHA, right? So turn. So in this instance, we need to turn. And I almost forgot something I'll come back to in a second. All right. All righty. Let's scroll out. Come on, maybe. There we go. Let's turn to a higher page. It's always higher, right? So, contrary. Okay. Contrary. We got a higher LHA of 301. Okay. Now, we want to make sure we're going into the right latitude to get our Z. Let me get my straight edge. 16 right here, 119.1. Okay, let me just mark that other one off. 119.1. Okay, 119.1. Okay, so now the Z difference, you're getting the difference. All right, so you're going to take whatever number is higher. It can be this column or it can be this column. Okay, whatever number is higher, and you're going to get the difference. So in this instance, it's this one. So 119.4 is higher. So 119.4 minus 118.5. That is going to give us 0.9. All right, 118.8 minus 118.5. 118.8 minus 118.5. That's 0.3. And 119.1 minus 118.5, 0.6. 0.6. All right. So now these numbers in the Z difference column is going to be either a plus or a minus. How do we know if it's a plus or a minus? Let's go back to our book. Okay. Pub 229. XXIV. Let's take a look at our table. So if we go in here, we see that our Z diff right here, right? Okay. We see, okay, 73.9 for our base Z, right? And then 72.9 for our tab Z. I see that if this number is less than this number, it's going to be minus. Let's take a look at the next one. Let's see. 73.9, 74.1. This number is higher than this one. So it's a plus. So if ever I forget, I can always reference my table, and that will point me in the right direction. That will get me right back on track. Like I said, your head is overloaded with so much material. I mean, I don't care if you're a Hawsepiper or you're academy person. Your head is overloaded when you're in this test prep phase. All right. So just try to take some stuff out of it and make it simple. Okay. All right. So I know that all these numbers here are higher, so it's going to be a plus. Plus, plus, plus. Those are positive numbers, basically, okay? So, Z diff times the increments equals, nope, Z diff times the increments divided by 60 equals the correction. How do we know that? From referencing our table, if we ever forget, okay? Right here. Times this divided by 60 equals correction. All right? Right there. All right, 2.9 times 0.9. 2.9 times 0.9 divided by 60. And 0.04 plus 0.04, okay? 11 times 0.3 divided by 60. 0.05 plus 0.05, okay? 55 times 0.6 divided by 60. 0.55 plus 0.55, okay? So I'm going to add these up. Plus 0.04 plus 0.05, and that equals 0.64, all right? Now, we're looking at our correction, right? And we don't need 2 decimal places. We just need 1, okay? So I'm going to carry this over here, 0.6, and it's a positive number, all right? Because these were all positive, or your total corrections equaled up to be positive. Some instances, it can be negative, but in this instance, it's a positive. And if you keep following with me and we go along through all these problems, I'm pretty sure we'll come across to one of those ones I can show you an example of. All right, so plus these 118.5 plus 0.6 correction, 118.5 plus 0.6 equals 119.1. Our Z is 119.1. Now, I have this question over here. LHA greater, what's that? Let's go back to our pub 229, all right? And we're almost done, okay? So simple. And I don't have to scroll far for this one, all right? I'm going to go right here. At the top and bottom of pages, right, you're going to have something, okay? Why in the world is this thing not? Here we go. Okay? The top and the bottom of pages, you're going to have something. Come on now. Come on now. Here we go. Messing me up. Okay. Top and bottom of pages. Let's get some of this stuff out of the way. Get some of this stuff out of the way. All right. So, if you look right here, you see that says south latitude, okay? But we have a northern latitude, okay? So we're going to go here with this rule. These are basically rules, okay, that you have to follow. All right, this is the last bit of this pub 229. Then we got it simple, okay? In this instance, we have north latitude, right? Okay, our latitude was north. So it says LHA greater than 180 degrees, ZN equals Z, or LHA less than 180 degrees, ZN equals 360 degrees minus Z. This instance, we have LHA of 300 degrees, right? It's greater than 180. So we know that Zn is equal to Z. All right, so that's done with that table. Zn is equal to Z. So, and what is Zn? It is our true bearing, all right? It is the true azimuth bearing, okay? Now, this is the simple part, but it can trip some people up. So, I'm going to write GE, right? TVMDC. What is G? PGC. What is C? PSC. Your T is your true, okay? This is variation. This is magnetic. This is deviation. This is obviously compass. And this is your error, okay? Pretty sure you guys, if you're this far along, I'm pretty sure you guys know this already. But let's write it down anyway. So, plus east minus west. Okay? From here to this line. And then from here it's going to be plus west minus east. Okay. And you got certain ways to remember certain things about this. Sorry for my lack of better words, but this is how I learned it. True virgins make dull companions. I apologize. And it says true virgins make dull companions at weddings. That means add west. That's a certain way people remember certain things. All right. So I mean that's just how I learned it, and I apologize. I learned from a sailor, who taught a bunch of sailors. So my apologies. Okay, so I'm going to take my true, which is 119.1, right? I'm going to take my variation that they gave me at the beginning, 3 degrees west, right? And I know the bearing that was shot was 119 degrees PSE, right? Let's see, 119 degrees PSE, bearing of the sun, okay? So now it's easy. I can just do addition or subtraction. 119.1, because we're going this way, right? 119.1, and we have 3 degrees west. So west, we're going to add. So 119.1, I have it right here, 119.1 plus 3 degrees. That's 122.1. 122.1 of my magnetic, okay? Now, deviation. This is going from here to here. Obviously, it has to be subtracted, right? So 122.1 minus 119, right, is going to give me my deviation. My deviation is 3.1. And since it's negative, right, it's going to be east. Because it was a negative number to get from here to here, okay? This is my deviation. And what was the question asking? What is the deviation of the magnetic compass? So when you got the Coast Guard, right, you want to answer the closest answer. What's the one you want to choose? The closest answer. In this instance, we have D, 3.2 east, okay? And that should be it. Follow, like, subscribe, comment, suggest. I mean, I know this might have took a long time, but my wife, she kind of critiqued my shorter video, and I wasn't as enthusiastic as I should have been. So I apologize, and I look forward to working with you guys in the future. This is Captain Alfred Jamal Watson, and I'm signing out. Have a good day.